Hello, everybody, and thank you for joining us today. Welcome to our webinar on advances in energy efficiency, EM&V. This webinar is going to run for about 75 minutes, during which time we'll have 4 primary speakers. First, 2 of them will be going through a presentation on a uniform methods project, and then our other 2 speakers will be presenting on what is known as M&V 2.0. All the phone lines for you, the audience, are muted. If you do have any questions, and feel free to provide them, you can type them into the text box, and we'll do our best to get them answered today during the webinar. The webinar is also being recorded. The recording and the slides will be available at the Lawrence Berkeley National Lab webinar website. That's listed on this site, and will be listed on some of the other slides in the presentation. The slides are actually up and available now on the website, and the recording should be available shortly. I want to note that the funding for this webinar is from our U.S. Department of Energy's Office of Electricity Delivery and Energy Reliability. And the Berkeley Lab is coordinating this series with input from and collaboration with DOE, of course, but also the U.S. Environmental Protection Agency, the National Association of Regulatory Utility Commissioners, and the National Association of State Energy Officials, who I all want to thank for their continuing support. I also want to thank our outreach sponsors that include the International Energy Program Evaluation Conference, which by the way, is having their every 2-year U.S. conference this August, and you can check it out at iepec.org. Other outreach sponsors include the American Council for Energy Efficient Economy and the regional energy efficiency offices, including the Northwest Energy Efficiency Alliance, the Southeast Energy Efficiency Alliance, and the Northeast Energy Efficiency Partnership. So as a bit of introduction, let me start off by introducing myself. My name is SteveShiller, and I'm an affiliate and senior advisor in the Electricity Markets and Policy Group at the Berkeley Lab. I've worked in the energy industry for many years, with a great deal of that time focused on efficiency and demand response, distributed generation. But one of my areas of focus is on evaluation, measurement, and verification, or as we call it, EM&V. And I'm fortunate to be the facilitator of this webinar series. The Berkeley Lab, which is hosting these webinars, is supported by the U.S. Department of Energy, and it conducts non-classified research operated by the University of California. The Berkeley Lab, also with funding from the Department of Energy, provides technical assistance to state agencies, primarily state energy offices and utility regulatory commissions. Before I say a few words about the technical assistance, so let me mention our disclaimer here, which essentially says that DOE, the Berkeley Lab, the University of California, and anyone who's probably ever known me or ever will know me takes no responsibility for what myself or the other speakers are going to be saying today. I mentioned the technical assistance in the prior slide. So LBL provides this independent and unbiased technical support for utility regulatory commissions and energy offices, tribal and regional entities in a wide range of energy areas such as energy efficiency and demand response, renewables, and a wide range of the very current grid topics that many of us are facing. Contact information for the technical assistance is available via the website that's listed here. And for those who don't write too fast, again, these slides will be available. They're actually available now on the recording up shortly. And if you want to, for this webinar itself, you can just simply Google LBL EM&V webinars, and it will pop up. In terms of this webinar series, these webinars are designed to support activities for documenting energy savings and other non-energy impacts of efficiency programs. As mentioned before, it's funded by DOE and with EPA, NARUC, and NASIO, and the other organizations I mentioned for support. This is actually our 9th webinar in the series, and the recordings of the past ones, both audio and slides, is up on the EM&V webinar site. I want to mention that our target audience for these is primarily utility commission, state energy office, environmental departments, and all those others involved in operating energy efficiency portfolios. But of course, we also see value to many others, and all are welcome to join us in these. The next webinars, we're hoping to have several more on these EM&V topics, and they'll be noticed on the EM&V website. Our next webinar hasn't been firmly scheduled, but we expect it to be in late June or maybe after the 4th of July holiday. And it's totally scheduled to cover cost-effectiveness evaluations of projects and programs. Also, by the way, speaking of webinars, I want to mention an upcoming webinar that is very much related to the topics we've covered in our series. This one is a state and local energy efficiency network, the C-Action Network webinar. It's on estimating the long-term impacts of behavior-based programs, and you can see the website for that here on this slide. So moving on now to let's get going on today's webinar. Let me just start off by saying, as a way of introduction, that we all, people in this industry, have been evaluating and measuring and verifying the performance of efficiency projects and programs in this country for about 40 years or so. And over that time, we as an industry have been improving and making advances in this field of EM&V. Having myself started in really actually a different century, I'd say that things have accelerated recently because of, first and foremost, an increasing interest in efficiency. I'd say efficiency really is no longer just an afterthought. It seems to be offsetting all natural growth in energy demand and perhaps then some. And thus efficiency, or not wasting energy as I call it, really does matter. This has meant more interest in EM&V from the government agencies that are using funding to incent efficiency, but also really for efficiency planners who now realize end-use consumption projections really do matter. And lastly, but perhaps more important, is that there have been improvements in EM&V standardization, data access, analytical tools, all part of the data revolution. So with that, it has led to some improvements that we want to talk about and advances in this webinar. First, we're going to be going over the U.S. Department of Energy's Uniform Methods Project, known as UMP or UMP by some. And under the UMP, DOE is developing protocols for commercial and residential energy efficiency measures and programs, as well as some cross-cutting protocols. And while we're perhaps at M&V 8.6 or something, M&V 2.0 is a term applied to advances focused on advanced and automated analytics and using the increases in data availability and granularity. So I hope you'll find these topics interesting and helpful in your work. So we'll do these two presentations, hopefully with some time for clarifying questions after each one, and then some general discussion time. Let me introduce then our speakers. I'll do introductions for each as we go forward here. The first, for the Uniform Methods Project, we have Mike Lee and Arliss Reynolds. Michael Lee is a Senior Policy Advisor in the Office of Energy Efficiency and Renewable Energy at the U.S. Department of Energy. He focuses on supporting states with resources and technical assistance to help them with achieving their energy efficiency goals. And one of his focus areas is this area of EM&V. Michael directs the Uniform Methods Project, which he's going to be talking about, is a lead for the C-Action EM&V Working Group. Prior to joining DOE, Michael worked at various state agencies in Maryland, including as the Chief of Staff for the Maryland Energy Administration. And then Arliss Reynolds, who's also going to be talking about UMP, is a principal in CADMAS's Energy Services Division, and she provides EM&V expertise to stakeholders in the utility and government, nonprofit, and private sectors. And during her ongoing career, Arliss has provided technical oversight for impact evaluations in residential and commercial sectors, done on-site work, and done complex project analyses and audits. And before joining CADMAS, Arliss was a senior analyst in the Energy Efficiency and Evaluation Group at National Grid, and she is a mechanical engineer. So I'm going to let Mike and Arliss take it from here, but first I want to give you all an opportunity in the audience to participate in a bit of a poll here as to your familiarity or not with the Uniform Methods Project. So if you can take a few seconds here to indicate whether you're familiar with it, you've used it, or perhaps not familiar with it. So I don't have any music to play while we do this, but if you'd like, you can hum along to yourselves as we rack up the results here. Got about 3/4 of the folks responding here. Just wait a few more seconds to see if anyone else would like to chime in. Okay. So skipping to our results here, it looks like we've got a good mix here of folks that have used the UMP, are using it, and those who are familiar with it, but also a fair number of folks who are not familiar with the UMP. And so I think for Mike and Arliss, you have a good opportunity to spread the word and talk about what's happening here. So with that, I'm going to go on mute and let Michael take it from here. Thank you.
Great. Thanks, Steve. This is Mike Lee at the U.S. Department of Energy. And as Steve just mentioned, the first part of the webinar on the Uniform Methods Project is really going to be sort of more intended to be for an audience who isn't really familiar with the Uniform Methods Project. So those of you that are sort of have been lead authors or contributors to UMP, you probably already know some of this content, but I do want to I do see a lot of people on the webinar that are part of UMP, so I just want to thank you for your contributions along the way. So with that, I'm going to sort of lead it off, and then towards the end of the UMP section, I'll transition to Arliss, and she'll take it from there. So this is what we're going to cover. We're just going to sort of share with you a little bit about what the Uniform Methods Project is, some of the things that we've done and accomplished, share a little bit about what the process is like so you get a sense of how each protocol is developed. And then we're going to wrap up and talk a little bit about how we see UMP being used by various stakeholders. So what is the Uniform Methods Project? UMP consists of numerous individual chapters, and in each chapter lays out a protocol for calculating savings for a particular energy efficiency measure, and you'll see that a little bit later in the presentation. UMP addresses the most common residential and commercial efficiency measures in ratepayer-funded programs. It also includes measures that are found in industrial programs as well. UMP presents step-by-step calculations for determining primarily gross savings, but to some extent some of the protocols address net savings. And then we also have a section of UMP that addresses cross-cutting evaluation topics. So those would be things that would apply across different measure protocols, and that'll become a little bit clearer as we move through the presentation. So here I'm going to just talk a little bit about some of our goals and the purpose for creating the Uniform Methods Project. The purpose of the Uniform Methods Project is to bring more consistency and transparency to how savings is determined for the most common energy efficiency programs run by utilities and other program administrators. We believe that this will increase the credibility of savings estimates and lead to greater investment in energy efficiency. Greater consistency in savings calculation also allows us to make meaningful comparisons of savings from similar programs from one utility to another. One of the other benefits is that it sets data requirements early on so evaluators and program implementers can proactively plan for data collection. And so those are just some of the goals and the benefits. There's a longer list on the slide there, and if anybody's interested, I can sort of elaborate on them in the Q&A session. Okay, so in terms of who the audience is for the Uniform Methods Project, the protocols were developed with a wide range of audiences in mind, as you can see here on this slide. Jurisdictions without a TRM or other EM&V infrastructure will find UMP to be a useful foundational document. Regulators who direct their utilities and evaluators to use the protocols can be assured that the methods used have been developed by a team of experts and are technically sound, and we'll explain that a little bit later. Program administrators can benefit by using UMP in their RFPs and know what methods their evaluators are proposing. In addition, if approved by their Public Utility Commission, the program administrator can also know that the savings will be accepted by their regulator. As mentioned earlier, program implementers will know the data that they should collect from the start, hopefully reducing the cost of having to collect data later. Evaluators can benefit by knowing their staffs are quantifying savings using the methods accepted by the evaluation community. So on this slide here, this is sort of a slide that we share with the authors of each of the individual chapters, and it just talks about what the expectations are for the authors as they work to develop their chapter and their methodology for their measure that they're working on. So the first is that each measure protocol should clearly specify the recommended methodology for each step. Each alternative method or step should be clearly labeled as an alternative. And just in case you didn't pick it up, there are basically two kinds of chapters within the Uniform Methods project. One is something we call the measure protocol, and that's basically where you take an efficiency measure like lighting, and then that's how we sort of go through how you quantify savings for that measure. And then there's the second type of chapter that's found in UMP is what we call the cross-cutting chapters, and those are things that address issues that would be used in numerous or several of the measure chapters, such as something like how to do metering or how to do sampling, some things along those lines. So in terms of back to the principles, each chapter should have a cover sheet or appendix that lists the main elements in the recommended methodology. Number 3, each measure protocol should reflect how evaluators should or currently determine the savings. And this is a key part. Methods should not be aspirational unless it is reasonable to expect evaluators to adopt this new method. And so what we're trying to do here is document what are the existing practices that are generally accepted by the evaluation community and the broader stakeholder community for energy efficiency. So we're not trying to sort of pioneer new ways of measuring savings that, may utilize the latest technology or anything like that. I mean, there is a role for that, and DOE does do some of that work, but that is not sort of this part of the scope of the Uniform Methods project. So for number 4, if a measure protocol includes a decision matrix to identify the correct method, the protocol should include a cover sheet for the most common cases. And so this is really just to help give examples to the users about sort of how some of these decision matrices play out. And then number 5, this is sort of tied to what I mentioned earlier. Each measure protocol should reference 1 to 3 M&V studies where the protocol can be applied to or can be seen applied to a large extent. So this goes back to the point where we're really just trying to document the existing best practices and not sort of pioneer new territory. So the next set of slides is just going to walk you through the different phases that the UMP has been through and the different topics that get addressed. I won't read through all of the things here, but you can see on the left there are a bunch of individual sort of efficiency measures. And we attempted to create protocols for the most common measures. And so our estimate was about, if we could get to about 15 measures, we would be able to sort of account for, somewhere in the order of 2/3 to 3/4 of the energy savings that are occurring through ratepayer-funded efficiency programs. And on the right, you'll see some of the cross-cutting protocols that were developed. And then here's phase 2, where we added a bunch of additional new measures. And then we added a net savings cross-cutting protocol. And then on the right, you'll see phase 3. And so in phase 3, we just released the protocol for combined heat and power. And we actually just released strategic energy management 2 days ago. So that is, the slide is already outdated. So those are all available on the UMP website. And then in terms of phase 4, phase 4 is really focused on updating the previously published protocols. And so as you'll all appreciate and come to recognize that, things change, which is not quite the understatement. And so one of the things that we want to do is really sort of stay on top of changes in the market and changes in sort of data access and availability or technology. And so we're constantly updating the protocols. So some of the protocols as are major updates as the ones that are listed here. And some of the protocols are just getting minor updates, and you can see the ones here. And hopefully you'll notice that for each protocol, there's we've listed who the lead authors are. So in some cases, it's a single lead author. In some cases, it's a team of lead author. But in any case, they're all working together with other sort of evaluators from different firms to make sure that this represents a collective thinking and not just any individual person's methodology or proposed methodology. So now I'm going to talk a little bit about how the project is organized and what the process looks like for developing a protocol. I covered some of this already, so I won't repeat that. I think the thing to highlight here is that UMP is developed in collaboration with evaluation experts and other energy efficiency stakeholders, and that's a key piece of why we think that there's value in UMP. So I'll spend a little bit of time here walking through how we develop a protocol. So I'm going to start with the steering committee, which is sort of in the middle of the slide. What generally happens is the steering committee will identify what are the measures that are most commonly found in utility portfolios, and we will then take those measures and figure out who are the expert evaluators who are doing evaluations for that measure type or that program. And then, so we get a list of the sort of experts from their peers, and then we identify one or two people to be a lead author in that. And those are the technical experts at the bottom of the slide. And so the direction to them, I shared with you some of their instructions, but the other thing that they're instructed to do is really to work with other experts for that particular measure. And so it really is meant to be collaborative and represent the best thinking across the industry and not for just one person or one firm. And then they go out and they develop their protocol. And then once they develop a draft of their protocol, it goes to one of our technical advisory groups. And the technical advisory groups are really looking at two things. Is this a valid way of measuring savings? And is it written in a way that it is usable by another evaluator? So that's sort of what the validity and usability delineations in that box address. And then once it goes through that process, we'll then present the protocol to the steering committee, and we sort of lay out big picture what the protocol does. And then once the steering committee signs off on that, then it goes to a public review process. And so that at that point, anybody can comment on that. And depending on the nature of the protocol and how much agreement there is about sort of the evaluation method, this full process can either be pretty quick or pretty long. So that's the methodology. So this just a little bit talks about the roles of the different, the main actors that are part of the Uniform Methods Project team. DOE is the sponsor, we fund it, and then NREL sort of is the primary manager of the project, and they run some of the processes like the public input process. And then CADMIS, and you'll hear from Arliss a little bit later, sort of really runs the technical side of the project, and they sort of do all the interaction with the evaluators from across the different evaluation firms. And then we have a steering committee, which is made up of energy efficiency stakeholders. You probably have seen most of the organizations on it. And to the extent that anybody here is interested in being a part of the steering committee, it's not a huge commitment, so feel free to be in touch with me or Arliss. I talked about this a little bit. These are the different groups. We have the technical advisory group, the technical experts, and then some technical advisory group experts. I think the only thing I want to highlight here is that the technical advisory group is really meant to be a group of the thought leaders in the evaluation industry. So they're commonly sort of the head of the evaluation practice for a large firm is essentially where most of the technical advisory group members come from. On this slide is just a sort of pictorial illustration of the process that I laid out a little bit earlier, in case this is a little bit easier of a way to understand how we sort of go through the process of developing a protocol. This is just a sort of a representation of some of the technical experts in the technical advisory group. This is by no means the full list. We couldn't cram that many logos onto a single slide. But I think in our estimation, we have included probably around 3/4 of all the evaluation firms that work in North America. So again, this is really meant to sort of be something that DOE initiated, but sort of brings in stakeholders from across the evaluation industry. And part of that is because the UMP protocols are voluntary, and so what we wanted to do is create buy-in and get stakeholder acceptance for some of the work that we're doing. So I'm going to turn it over to Arliss Reynolds from Cadmus at this point. She's sort of the principal on the UMP project, and she leads all the day-to-day work on UMP, and she's going to talk a little bit about how UMP is used, and then we're going to sort of give you a quick snapshot into what one of the individual measure chapters looks like.
Great, thanks, Mike. So Mike describes that we have 23 protocols, some measure-specific and some cross-cutting protocols, all of which have been approved by our technical advisory group, and all of which are publicly available on our UMP website. But we've posted all of these as reference documents. We try to make people aware of the protocols as a resource, and we have some work to do there for the 40% of folks on this call who said they weren't aware of the project. And we try to educate on how the stakeholders can use the protocols in their delivery of energy efficiency programs. But again, none of these protocols are mandates. Adoption or use of the protocols is all voluntary. So what we've listed here are 3 pathways for adoption. A regulator could formally adopt the Uniform Methods Project by requiring evaluators to follow UMP protocols when they exist for specific measures. More commonly, we see program administrators using RFPs or contracts with their implementers or evaluators, requiring them to use the UMP protocols where appropriate. For example, for evaluation of a residential lighting program, use the protocol for residential lighting. And we also hope that our evaluators in the industry are bringing protocols to the table even when they're not asked. Presenting these as the industry-accepted, kind of validated methods for impact evaluation. So we show on the next slide some examples of where we see UMP popping up. Oh, I have control here. Where we see UMP used in industry over the past 4 or 5 years. We've seen EMP Reference in evaluation framework or guidance documents. I mentioned RFPs, technical reference manuals are starting to reference UMP protocols as the source of methods for estimating savings. And we see evaluators' proposals and evaluation reports also indicating that the methods used to verify savings are consistent with UMP protocols. We were very pleased a couple years ago to see Uniform Methods Project also referenced in the Quadrennial Energy Review as an important source for standardizing the methods that we're using to calculate energy efficiency impacts. And there's also been a lot of discussion about standardization. We're showing an example here of a report in the GreenBiz blog about Uniform Methods Project really paving the way in standardized methods on a national level. So we'll get a little bit back into the weeds to provide some detail on the specific content that we include in each protocol. We have here a list of the 6 primary sections of content that are in our measure-specific protocols. And the 2 lighter colored blocks on the bottom are new sections that we're creating as part of the first set of revisions to protocols. And I'll walk through each of these using the example of the protocol for whole building retrofit programs. So the full name of this protocol is the Whole Building Retrofit with Consumption Data Analysis Evaluation Protocol. So in this case, we've actually described the evaluation method directly in the protocol title. This protocol was authored by Ken Agnew and Mimi Goldberg from DNVGL, and they are working on a revision that we expect to be published in July. The original version was published in 2013. So the measure description is pretty straightforward. It describes some of the characteristics of the measures addressed in the protocol. Then we have a section on the application conditions, and this one is very important because it describes the conditions under which the protocol does or does not apply. So sometimes we'll see, in this case, we describe that this protocol applies where the baseline is the prerequisite condition. So this protocol is not designed for a new construction baseline, for example. The protocol also requires that sufficient data exists before and after installation. You can't use the methods for this described in this protocol if you don't have all of the data required. The third section on savings calculations describes in detail the methods, two primary methods for calculating savings. In this case, a two-stage approach and a pooled approach. And then the fourth section is really the meat of the protocol. This is what describes the measurement and verification approach. We typically start by specifying which option of the IP MVP protocols is the recommended option. In the case of whole building, IP MVP option C, which we commonly refer to as building analysis, is the method of choice. We describe that verification is not required for this type of approach, describe the data requirements, and then there's a detailed walk through the methods, including the data requirements, specific sources that you might use for weather data, for example, data preparation, and the data analysis. Our chapters typically include a discussion of how you design a sample for that program. In this case, the protocol describes that you don't really have a sample because the methods include all program participants. We also have a section on other evaluation issues, and this is where authors may have addressed net to gross considerations, for example. In the case of this whole building protocol, they describe other areas beyond the whole buildings where you might apply the same method or alternative approaches to designing comparison groups. We have a references and resources section, which we're expanding for a whole building, and our intent here is to not only provide references for the information provided in the protocol, but also provide references for examples where the protocol has been used in evaluation. So you can read a report that demonstrates the method in practice. And we'll be adding two new sections as they described. One, looking back, which will describe the changes that have been made to previous standard practices. And then another section on looking forward. And this will be an important one as well. As Michael mentioned, our methods are constantly evolving. This looking forward section will describe some of the current research, changes in the market, such as increased availability of AMI data, that we expect to change the standard method for this type of evaluation going forward, but maybe isn't broadly accepted enough or proven enough in the industry to be considered the common practice now. So with that, I'll let Steve take back controls on whether we have time for questions now or we'll save that for later.
Okay, well, Michael and Arliss, thank you very much for the presentation on the Uniform Methods Project and protocols. I do have a category for a clarifying question that's come up in a couple questions from the audience, and that's around net and gross savings. So I was wondering if one or both of you could talk for a minute or two about, one, first defining for the audience members who are not familiar with what is net and what is gross, whether the protocols in the UMP focus mostly on gross, and talk a little bit about the net to gross cross-cutting protocol. I know I've given you a lot to do in, say, 2 minutes, but if you want to take a shot at that, and in terms of perhaps putting you on the spot for the net to gross protocol. I actually have it open on my desktop if you want me to briefly mention what's covered in that, or you can cover it. You're probably both very familiar with it.
Sure. So I'll try to answer a couple of the questions here. So the measure-specific protocols typically are describing methods for estimating gross savings. So those are the savings achieved by program installations or program activity. I mentioned that there's a section in those measure-specific protocols on other evaluation issues where the protocol will address some considerations around net to gross issues. Often it's whether net to gross values are typically high or typically low for that type of measure or program. But we don't typically describe the methods for estimating net savings within the measure-specific protocols. The net savings we define typically as the fraction of gross savings that are attributable to program activities. So the programs achieve a certain amount of gross savings, but typically only some fraction of that. Hopefully a large fraction of that are attributable to program activities or would not have happened without program activities. So the methods to estimate those net savings are described in a cross-cutting chapter we have on net to gross savings, and that's also available on our website. That chapter is a little bit different. It describes a suite of methods that are commonly used in the industry for different types of programs, and it's being revised now to clarify some of those methods and tie some of those methods to specific program designs.
Nothing to add on my part.
Okay.
Steve, did we lose you? And I will take my mute button off and say thanks for that. And did a good brief presentation on a very complicated and controversial subject within our EM&V field of sorting through attribution issues. So let us now turn to our second part of our webinar on M&V 2.0. As I start to describe our presenters here, let me put this poll before you again so folks can take a chance and fill out the survey here to give us a sense of whether you've used or are using M&V 2.0, familiar with it or not familiar with it. So we have two presenters to talk about M&V 2.0. First, Dr. Ellen Franconi is going to be starting off, and she's the Energy Analytics Manager within the Buildings Practices Group at the Rocky Mountain Institute. Her work involves creating awareness and developing methods to support building efficiency as a grid resource. Her areas of expertise include building simulation modeling and M&V. She's also currently the chair of the IPMVP M&V 2.0 subcommittee, and she has her doctorate in building science. And like our other speakers, we have two CU Boulder alumni here. The other one is Tim Gitterman. Tim is the Director of Measurement and Optimization Solutions for Energy Savvy. Tim brings 10 years or so of experience in energy engineering and EM&V. Most recently at the firm Navigant, but he's managed multi-year EM&V studies and market characteristics and worked on energy codes and such. And he was actually previously at the Colorado Governor's Energy Office, and he has degrees in engineering also from CU Boulder. Also, I want to mention, they'll talk about this, Ellen and Tim, as well as Michael, were co-authors of a recently released just in March of this year, excellent report from RMI titled The Status and Promise of Advanced M&V, and I think they'll be talking a little bit about that as well. So with that, we have our poll results in. Let me put this out for folks and show that we have, most folks are familiar with M&V 2.0 or have used it, but we do have a sizable portion that are not familiar. So hopefully at the end of this presentation, everyone will be very familiar with it. So with that, I'll let Ellen take it from here. Thank you very much.
Great. Thanks, Steve. So the title and the subject of our presentation is based on the white paper that Steve mentioned that RMI and partners wrote and was released earlier this year. And I'll be reviewing the key concepts introduced in the paper, and Tim will follow excuse me, with examples in case studies that they've applied in efficiency program applications. So I'd like to start off by discussing what this term advanced M&V or M&V 2.0 means. After all, we can barely agree on what to call it. It would be good if we got some clarity about what we mean by it. Well, basically, it refers to whole building M&V methods that utilize typically utility billing data. But what's new and different about it is that the data is in a more granular form. It could be daily, hourly, or 15-minute. And these timescales for data collection are becoming more and more commonplace due to the increased prevalence of AMI meters. So now with this more data, it's leading to new advances, well, new developments in advanced analytics and a movement towards more automation. And these three features taken together allow savings to be determined in near real time. And this provides a lot of extra value compared to conventional methods that for M&V that typically have been happening well after the point in time in which the measures have actually been installed. And in addition, when you use more data, you can develop a statistically robust M&V model within a shorter time span. So for example, in the past, when one would use monthly data to do a whole building savings evaluation, you would need 1 year's worth or more before you could develop your M&V model. But with interval data, you have more points. So that model can be created with a shorter time span. But additionally, because of this more data, it has the potential to be more accurate. And as a result, we now have the potential, are able to detect savings for smaller efficiency projects. And this is particularly interesting as there is a movement for programs to go towards pay for performance and trying to pick up, instead of a widget-based approach to program design, but something more holistic where you can capture operational and behavioral changes that typically aren't as big as the capital improvement measure, that now with whole building methods, with M&V 2.0 approach, we actually have hope to do it the operational improvements this way. Okay, so this is the cover shot of the white paper that RMI and partners wrote. As Steve mentioned, 3 of the authors are on the call, Mike, Tim, and me. And as you note, the authors, you might realize we represent a diverse stakeholder group, and that was by design. Because one thing that's happening with the data being available in more real time, there's more reason for us to talk together. And we were all interested to figure out the challenges and opportunity for M&V 2.0 and how to leverage it to advance energy efficiency markets. And it's a really approachable, easy to read foundational document, and I encourage everybody to download it and take a look at it. So the kind of big picture promise of M&V 2.0 has to do with a couple of key attributes of the new approach. The first is the timing getting the results in near real time. The effect is that these different stakeholders who in the past have conducted M&V at different times for different reasons, can now work more together using the same data set and applying similar methods. So this can push us towards less siloing, more sharing, and more process efficiency. For example, a traditional ESCO might conduct M&V after a project has been installed for a year, but a program evaluator might start looking at the building level performance or gross savings to a program after a couple of years when enough buildings have participated to give them a sense of how it's going. But now that results can be received in near real time, they both are motivated to get information sooner, more timely, and are applying the same basic methods. So we are all in this together to define it, figure it out, to have shared platforms for sharing data, and even the algorithms for conducting these advanced analytics. Let's see. Also, it's probably worth mentioning here on the diagram on the right, upper right, just about what's the difference between M&V 2.0 and EM&V 2.0. And as you can see, there's this big subset within EM&V that is the gross savings component. So in the circles I run with, this M&V 2.0 is embedded within an EM&V 2.0 approach, and that's what's meant by that. Although I imagine with more data there and more advanced analytics, there could be this additional analysis approach that EM&V also takes on. So talked about, this things happening at the same time, and that's allowing for more collaboration and more consistency in methods, efficiency in processes. But it's also leading to the advanced analytics. They just have better resolution. So now it can start to capture the load shape of energy use with these baseline models. So we can start to determine savings by time of day. So this is really important if we want to evaluate energy efficiency as a distributed energy resource, and something that is more comparable to a traditional supply-side resource. So this is quite exciting for new utility business models and moving more towards aggregators and sort of energy efficiency as a transaction. So right about now you might be thinking, well, that's all well and good at this high level, but how does it help me as a stakeholder? Well, different stakeholders benefit in different ways, but the benefits all stem from this increased timeliness and improved resolution, which makes for more actionable insights. For example, an ESCO can use their whole building M&V models to get savings results sooner, and this can help them manage the risk of potential underperformance in their contract. Also, because the data, the models have this higher accuracy and are done in more real time, they have expanded applications. So now they can be used to support fault detection, almost like a continuous commissioning, and this can help them to expand their service offerings. So similarly, program managers and administrators, they can start to get results more quickly, and they can do in situ adjustments almost in program designs to make sure the programs are reaching their goals. And of course, moving more towards like grid planners, well, now they can get this, figure out savings by time of day and even by location. So they might work with the regulators and the program designers to target particular areas that are constrained on the grid to address, the peaks and just be more of a targeted program to address grid issues. Over the last couple of years, there's been a dramatic increase in the number of M&V 2.0 tools available on the market. And there can be a lot of differences between these tools. So within the paper, we do summarize some primary characteristics. that you should keep in mind when you're investigating tool options. The first is the sector focus. Is it for a residential, commercial, or industrial building? Maybe it's for a particular building type within the sector, or maybe it serves multiple building types. Another is the tool design intent. As shown in the graphic, you see the measurement verification is just one layer. But these analytics can be coupled with additional data. That data could be what we say behind the meter, like in the building automation system, for example. And so you can actually get into more and more detail and have this analytics with supplemental analysis, more data, perform more like fault detection diagnostics, do automated audits, and definitely increase your customer engagement. On the other side, you could also couple that M&V analytics and the data with more higher level program information, and that could be of greater value for a program manager or administrator. So you really want to understand what is the design intent of the tool. Another consideration is the degree of automation. For example, in a service provider kind of tool, this could be fully automated where they're sending email alerts and almost like a person just has to press a button and some control change will happen. Alternatively, somebody might put forth this tool and load it on the desktop of the building operator, and it's more of an aid to them to better understand the building, but it's not fully automated. Of course, the M&V method is important, embedded within their procedures. What standard or protocol are they following? Good to get clear on that. And then the transparency. What is meant by that is some of these tools, they could be open source and everything is fully disclosed, or it could be much more proprietary, and they would be less willing to tell you all the details. Maybe some of it's part of their intellectual property and they don't want to reveal it. So that would also be something good to know. So I hope in this brief introduction to M&V 2.0, you start to understand the benefits and the big picture promise, and start to agree that there's good reason for the excitement around this topic. But there are still issues that need to be addressed before it can reach the full potential. For example, the users that want to use the data need to have access to it, and because the methods are automated, it's best that the data are clean and that it's presented in a consistent format. So it can be easily imported into these algorithms. And also because the approach is new, industry would benefit from understanding how to best get the methods incorporated into their workflows and also to understand the best applications. The model acceptance criteria, most of what's been developed and published in protocols, guidelines, standards have been based on monthly data analysis. So now it's time for industry to come together and get some agreement of what the new guidelines are for interval data. And as Arliss mentioned in their update of option C, I'm sure this is one of the things they're going to be looking at. The other is about the treatment of baselines. So this is a hot topic certainly as we go the gross and net discussion and as we move towards pay-for-performance programs. But it also represents an opportunity for tool developers. Instead of just going for one or the other, they could have several baselines that one could use, and this certainly would increase the usability of their tool. Cross-stakeholder information sharing. Again, now we have common interest to get things to be consistent. We can work with the same data, same analytics. How do we benefit from, getting up to speed on this jointly. And similarly, we can do this by different stakeholders working together to design and conduct pilots to effectively address the most pressing questions. So at the bottom of the slide, I list the title of our report again, and you should be able to easily find that by Googling it. It is available on the RMI website, and it's also been published as an LB&L report. And you can certainly copy and paste those two links there and get it directly. Okay, well thank you. I hope that clarified things a bit, and happy to answer questions, I guess, after Tim gives his presentation. Is that right, Steve? Are you on mute, Steve? Well,
yeah, Ellen.
Well, yeah. Why don't you go? Go ahead, Tim.
Sure.
Yeah.
I don't hear from Steve. This is Tim Gitterman with Energy Savvy. Thanks for the introduction previously, yeah. Steve. And Ellen, I'll just follow up, and I think we can take care of some questions after this kind of brief presentation. Okay. So what I want to do is provide some examples from applications in the field and kind of frame the M&V 2.0 discussion in this mostly utility and energy efficiency and DSM program level applications. And just for context here, Energy Savvy's experience with M&V 2.0 is really aimed and rooted in residential and small medium business. And there are others in this space and field that are better suited to discuss large commercial individual building M&V 2.0, and there's a lot of mention of that in the RMI paper. LB&L has some great work done on that side of things, but I guess each sector kind of approaches this a little differently, and there's different applications, use cases, and benefits to stakeholders. So just something to consider as we go along, and we can clarify with questions after. But I want to start with focusing a little bit on the challenges. And really, I think at the program level, one of the main challenges we see is a lack of timely and granular feedback on the results of energy efficiency and DSM activities in the field. So whatever phase the program's in, whether that's design or implementation or planning or evaluation, not having the right kind of data in the right form at the right time has consequences. And so to address these challenges, what we need to do is combine the best practices of EM&V, including the UMP whole building analysis methods that we just heard about, with the latest advances in technology. And these include cloud computing, automation, machine learning, and availability of more granular data. So to put simply, we need to sharpen the tools in the toolbox and put some new ones in there if we're going to advance this industry and do something about tackling these problems. And when we look at the bigger picture here, we also need to understand what actually happens at the customer meter if we want energy efficiency to truly count as a grid resource. So what does this really mean to combine these things in practice? Well, that means using computers to do an automated and continuous billing analysis, and that's either with monthly data, or we've done this with bi-monthly data, or interval data, as Ellen spoke about, and doing this across an entire customer base. This can be done in any particular sector, as I mentioned before, and as an example, with many of our clients, we pull in all of their residential customers' usage data, so millions of customers, on either a monthly or a weekly basis, depending on the frequency of the interval data and the desire to get that data transferred and the updates. And we combine this with project data to estimate energy and or demand savings. And in following the UMP, the Uniform Methods Protocol, it's essential that we incorporate these matched comparison groups. And at Energy Savvy, we strive for non-participant comparison groups wherever possible. And that's to control for exogenous change and ensure that the savings are actually attributable to program participation. And this is where computers are the right choice for this work. Machine learning to do complicated iterations of matching to find the most suitable comparison groups, and automation to do this repeatedly and to update the analysis as the data is made available. So as the crank turns, utilities and their stakeholders can get near real-time insight into results and then actionable intelligence. So what does faster feedback actually look like? Well, here on this slide is a real example from a home performance program. So in today's world, you'd have to wait until all the data is in and maybe 9 to 12 months after the program year is finished to get an estimate of savings. And that's that point way out to the right of the chart. In this case, M&V 2.0 is providing a reliable savings estimate halfway through the program year. Not only does this feedback have programmatic benefits, allowing for mid-course corrections, less costly and smarter QA/QC, and better contractor management, all benefits to just ongoing program management. But importantly, this feedback can enhance EM&V activities by providing accelerated time to insight for ongoing programs and for pilots, informing evaluation research. Where do you want to spend your budget? Where do you want to investigate and hone in on a program? And inform sampling and, of course, updates to savings values, whether those are in TRMs or other formats. And I should clarify, the savings estimates are the yellow line, and the dotted lines are a 90% confidence interval around those savings. So the key to all this, though, is to do this right. And that's really where the UMP comes in, tying all this back to those whole building analytic methods and the best practices that have been forged in evaluation over many decades. And this is where we take it a step further with advanced M&V by using machine learning and automation. So one of the tenets of the UMP's Chapter 8, the whole building method, is to control for what's called exogenous or external changes. It might be due to population trends, rate changes, economic things happening, non-degree day related weather events, etc. But it's to control that for those changes through comparison groups. And in statistical analysis, this is known as bias correction, which is essentially ensuring that your models are working and they're accurate. And we know this is essential when estimating savings from a whole building ongoing billing analysis, but the UMP is concerned with one-time estimates with 12 months of post-installation data. So when you want to do this in a continuous fashion, it turns out that using comparison groups really is the key to making that happen. And as you can see here, you can ask the question, would you want to make a decision around your program on the red line, which is not using comparison groups and not doing that bias correction and not controlling for those changes in an ongoing way? Or would you want to make decisions around the yellow line? And accuracy and reliability matter. And as this chart shows, not doing this right will give you insights and results that can't be trusted. So this all sounds great, but what I'd like to do is look at some results briefly from using this technologies on the ground. Now we have other case studies on our website, and some of those are more related to what we call program optimization, so driving out costs from QA/QC and better program management, as well as other integrated evaluation examples. But I'm going to drill down on just one recent one here. So DTE Energy in Michigan recently presented some initial results from an ongoing pilot with M&V 2.0 software at a conference in California just in April. And these next few slides are taken from that presentation. And the pilot demonstrated a few key things. So first, that M&V 2.0 is accurate. And the pilot set out to determine if M&V 2.0 software could align against traditional billing analysis methods to allow the utility to then make decisions about if and how they would like to use the tools going forward. And in this case, the software met all three pre-agreed upon validation criteria across the two programs being studied. Second, the early savings estimates are reliable, and the impacts can be understood during the program year, which reflects the charts that I showed earlier. Third, M&V 2.0 can detect savings in small amounts, really making it a great fit for behavioral programs. And additionally, M&V 2.0 can measure peak demand reduction. Obviously, when interval data is available, it's difficult to impossible to do with monthly data. And it also allows for the detection of the peak demand reductions, again, on programs such as behavioral or other maybe similar programs that have these kind of dynamic attributes about them with small changes across many premises or customers. And so finally, where I want to leave you with is that all of this comes together in the policy arena. EM&V really is rooted in policy drivers, whether it's in a jurisdiction or in a state. And there's a lot in this slide, but I have this for reference and you can refer to it later. But really the key takeaway is that it's not just vendors and software firms or evaluators advocating for new approaches. There's a lot of activity across the country and it's taking place in different forms. And there's really a genuine push towards measuring savings at the meter in a more continuous fashion. For example, some highlights here, there's language in New York's Track 2 order as part of their REV proceeding on advanced M&V. And New York's recently revised evaluation guidelines establish advanced M&V as part of the formal evaluation process for state energy efficiency programs and encourage its use and encourage budget sharing between programs and evaluation due to the multiple benefits to multiple parties. And in California, they're integrating measurement at the meter into their energy efficiency portfolio and embedding M&V into program delivery. Other states like Connecticut are working on pilots or asking for these services to be a part of the EM&V delivery like we saw in New Mexico. And Maryland and Massachusetts are actually looking at using what they call actual meter-based savings, so at the customer meter, to drive towards more performance-based models for delivering efficiency to their customers. So that's all I have for today, and I just hope anyone on this call finds ways to integrate M&V 2.0 into their portfolios in order to enhance and support their evaluation activities with the latest in technology and innovative methods. And I'll just turn it over to you, Steve. Thanks.
Great. Thank you very much for that, and to you and Ellen for making that presentation. As we move on, let me just ask you one clarifying question for you and Ellen, perhaps, on maybe talk a little bit at a relatively high level about how more granular data provides more statistically robust estimates. The type of data that you get from the AMI or others in using the M&V 2.0 technique. I don't know if Tim or Ellen, if you want to try to tackle that one.
Go ahead, Ellen.
I think the answer might be slightly different if you talk about gross savings versus net savings. So why don't I tackle the gross savings part? Certainly, obviously with all M&V methods, you want to find the best model for the building, and sometimes the model you choose, like an option C approach, isn't the best solution for a building. So that's always in place. But should an option C be a good fit for a building, we have found, RMI did some work, we had a sample of about 20 all-electric buildings, and we wanted to see what was the uncertainty in the savings estimates. So for each building within this portfolio. And we did find that, again, we had a client, they had really strict criteria. I think they wanted to, within a 95% confidence interval, see if the uncertainty was down at the level where they could do operational improvements. And though, it was tremendous. It was between some buildings it was higher, and those just wouldn't work. But some of them, the uncertainty associated with the savings, the total, baseline energy use was like 1%, 2%, 3%. So certainly you can get down pretty low. When you start aggregating those uncertainties at the portfolio level, it gets even better. And I guess that's where I'll hand it over to Tim.
Yeah, would you like me to jump in there, Steve? Or?
Sure, Tim. Why don't you go ahead, and I want to get to a sort of a general discussion for our expert panel, but go ahead if you have some more to add, please.
Just real quick, I think precision, uncertainty around any kind of savings estimate really relies around multiple variables, including what's the depth of savings, what's the amount of post-treatment data and how relevant is it to the measures installed, what's the number of projects, and the sample size is a really key driver there. So it's not just related to now we have interval data, we now have better savings. It just might enable a better baseline model and more certainty around that that fit, and certainly might also lessen the time needed to develop those baseline models, but there's still other variables at play that need to be accounted for.
Well, thank you. As we reach towards the end of our time for our webinar today, I want to throw out a general question that's come up in various themes and from our audience. And I guess I would summarize it for each of you on the panel to take a minute or two or a minute to respond to, which is, where's this all going? We have three common general approaches in EM&V for efficiency. The deemed or stipulated savings, which continues to be, in some way or another, a majority of the savings, certainly from utility programs, are determined with that. We have the M&V approaches, control groups, overlaying a lot of this is the M&V 2.0 that you've been talking about with improving analytics and improving access to data. And then with the Uniform Methods Project protocols, maybe just some comment from each of you as to how you see the direction of the methods and how the UMP fits into this, as well as the uses for technology and data. So what's your crystal ball showing? Where do you think the directions are headed with our EM&V field? So maybe see if anybody wants to jump in, or we can just go in the order of our presenters from earlier today.
This is Mike. I can start. I mean, I think UMP is about sort of documenting sort of our existing practices, and I think what Tim and Ellen talked about is a little bit of a look to sort of what's coming next and what's down the road. And I think there's going to be increasing value on how and what we measure in terms of energy savings. And I'm sure most of the people on this call have heard about this Brooklyn Queens Demand Management Project, and as energy efficiency becomes a solution to some of those types of local distribution system challenges, it's going to sort of force us to sort of continue to sort of advance in terms of how we measure savings, so that energy efficiency can be more value, especially if it's delivered as part of a dual sort of efficiency and demand response type program. So so I think there's going to be a lot of advances coming down the road.
This is Arliss. I'll add that I think as energy efficiency increases to grow in value, the scrutiny around how we're calculating savings will also grow, and we're certainly seeing that now. So where Uniform Methods Project isn't necessarily forging the way on new and innovative methods, it's going to be another effort to increase documentation of how we calculate savings and consistency or standardization in how we're calculating impacts of our programs is going to be really important to maintain the credibility of the work that we're doing.
In traditional, I guess, RMI style, we've got our eye on, transactions. I mean, going back to this term megawatts, which Amory Lovins coined. And so obviously we're quite interested in pay for performance and defining the baseline to be existing conditions to support more of this transaction market. But of course we recognize that different stakeholders verify savings for different reasons, and there could be a very good reasons to maintain those other type of baselines. And certainly by comparing existing building savings to these other methods like deemed savings, it can help improve them over time and make them more realistic.
Yeah, thanks. This is Tim, and there's a person named Tom Ekman that many might be familiar with in the Northwest, one of the sort of early drivers of efficiency and evaluation work, and certainly around deemed savings. And he said in a recent presentation in 2016, why deem it when you can measure it? And I think that gets at the concept that deemed savings today have a role and a place. It helps with program planning, it helps with accounting and certainty and reliability. But as the low-hanging fruit of energy efficiency becomes harder to get and less part of the programmatic outreach, and customer expectations for what they're getting from their utilities is changing, it becomes really essential that we match these new dynamic measures that are coming in forms of behavioral or home energy management systems or really smart widgets with smart dynamic ways to measure them, and that incorporate all of that data and are measuring on a continuous basis. And I think one of the ways this can start and move the industry forward is just by tracking actual savings as we go and beginning understanding what's happening at the customer meter in order to drive these decisions around how programs are designed. Once you have this ability to measure like this, you can drive new program designs that get at that and solve a lot of the questions of trying to put new measurement technology on old existing program designs. And so I think the role of the evaluator and the measurement technology that they use can really change and help bring efficiency to that next phase and truly make it something that matters on the grid.
Well, thank you all, and I certainly want to thank Michael, Arliss, Ellen, and Tim for your presentations and sharing this glimpse of the advancements that we're seeing in our field of EM&V. I feel like a TV show host in a long-running series of saying, stay tuned to our audience. There's more to come, but I think we've seen and heard today, the opportunities then provided to us by this increased interest in efficiency in general, but also the advances in technology, analytics, and data access that gives us for EM&V. So we will be ending here. On this screen here, you see the websites for various resources available, both for this webinar and the presentation, whose recording as well as the slides should be up shortly. Other resources available, as well as the technical assistance that DOE and the Berkeley Lab provide. So again, thank you to our presenters, and thank you to our audience for joining us. And we'll see you for our next episode in the EM&V webinar series. Thanks for your time today.